All right, jumping back into it, whether you came right back after the first lecture or whether you took some time, it doesn't matter because this is here for you. So, again, really quickly to review what we just went over, looking at the marginal means that allows you to understand or to determine whether or not there is a main effect. Again, for younger drivers, we average over both on and off cell phone. For older drivers, we average. So it's as if we're looking at one IV and its levels as if the other IV didn't even exist. So for younger drivers overall, whether they're on their cell phone or not on their cell phone, was an average of 5, 8, and 2. Older drivers overall, the average of 12 and 3 was 7.5. So the difference between 5 and 7.5 in the marginal means for older versus younger drivers shows that there is a main effect for number of accidents. Looking at on cell phone, 8 and 12 for an average of 10, and not on cell phone, 2 and 3 for an average of 2.5, we see a main effect for cell phone because 2.5 and 10 are significantly different from each other. Looking at the idea of whether there or not there's an interaction, we have one line that slopes and the other line that slopes even steeper. So even though they're both going in the same directions, they are not parallel. And so we do have an interaction. And again, we can look at the simple means. You can either subtract across or subtract down. 8 minus 2 is 6, 12 minus 3 is 9. 6 and 9 in number of accidents are different enough from each other. We would say, yes, interaction. We can do it also going down. You don't have to do both, by the way. Again, simple cell subtraction is either across or down. You don't have to do both. Doing both just confirms because you'll see that if you do it across or you do it down, there will be a difference. If there's no interaction, there will be no difference whether you go across or go down. So 8 minus 12, negative 4. 2 minus 3, negative 1. Again, we see that that's different enough from each other. So yes, we can say that cell phone and age have an interaction. Again, looking at the second cell, 5, 5, 5, and 5, we see no main effects, no interaction, and it's basically one solid line on top of itself. For the third one, marginal means are 5, 5, 6.5, 3.5. So main effect for cell phone, 6.5 and 3.5, different enough. Yeah. Main effect for driver, 5 and 5, no. Looking at the lines on the right, one is the same, one is going down. We see a crossover interaction, so yes. If we were to do the simple cells, 5 minus 5 is 0, 8 minus 2 is 6. We see a difference, 0 and 6. If you were to do it down, you'd also see a difference. 5 minus 8 is negative 3. 5 minus 2 is positive 3. They are different enough. So we can confirm through simple subtraction of the cells or by reading the graph that's not parallel, we have an interaction. Again, let's check the bottom one. We have 6.5 and 3.5 for older and younger drivers. We have 5 and 5 for cell phone, not on cell phone. No main effect for cell phone. We do see a main effect for age of the driver. Looking at the spreading interaction, we see that there is one. If we were to use this simple subtraction, 8 minus 5 is 3, 2 minus 5 is negative 3. That works out. Looking at the bottom, going down, 8 minus 2 is 6, 5 minus 5 is 0. Again, we have that same idea. So that just confirms, yes, we have an interaction. How would we explain it? For younger drivers, cell phones cause more accidents. For older drivers, cell phones cause fewer accidents. Or you can say that younger and older drivers have the same number of accidents when they're not on the phone. Younger drivers have significantly more when they are on their phone. Either way, it works. All right. So the way that we word things for a main effect, again, we're just looking at the two levels of one single variable, whether it's on cell phone versus not on the cell phone, or whether it's younger versus older. It's almost as if for a main effect, the other IV doesn't even exist. Here we see the same idea that we just practiced. In this example, in this study, people wanted to see if the type of training had an overall effect on scores. So we had two types of test. We had a verbal test, which is more like English, and we had a math test. And there were two types of training. Vocabulary training, which you would think would help for verbal, but maybe not for math unless you use word questions, and no training whatsoever. So again, here we have a 2 by 2 factorial design. 2 by 2, saying that there's two 2's means there's two variables. The first 2 is variable 1's levels. The second 2 is variable 2's levels. So here we have test type, verbal and math, and we have training type, vocabulary training versus no training, which would be their control group, right? Looking at it, that gives us 4 groups: verbal with vocabulary training, verbal with no training, math with vocabulary training, and math with no training. We also see on the right side and at the bottom the marginal means to let us know if there's a main effect. Just like we talked about with the Stroop task and with the simple effects, that people with the large bowls in chapter 10 took more pasta, ate more pasta than the medium bowl. Those with black ink or a black cover or gray cover did better than those with red ink or a red cover. Those are the effects, so they would be like the main effect here for one of the variables. Looking at the marginal means, we see 3.5 and 3. I don't know if you'd consider that different enough from each other. Probably not. I would say for test type, I don't see a main effect. But looking at vocabulary training, we see 4. No training, we see 2.5. That to me seems like a good main effect. So in this case, which one scored higher than the other? Remember a couple of homework assignments ago, probably the last one we did in class when we were actually in class, was looking at the direction of an effect. And direction of an effect just means which one is higher than the other. So in this case, this is the wording we would use. There is a main effect for blank such that this level is higher than that level. In this case, how would you say this? We don't see a main effect of test type, so it's not going to be test type. What was the other variable that I named? I called it training type, vocabulary versus none. So since there is no main effect for test type, there can only be one main effect. So you can see just by filling in the blank, there is a main effect for training type such that, and then again, we want to know which one scored higher than the other. Looking at the marginal means, vocabulary training was a 4, no training was a 2.5. So there is a main effect for training type such that the vocabulary training group scored higher than the no training group, or the group that had no training. And then when you're asking, is there a main effect for test type? We said no, 3.5 and 3 are not different enough from each other. So you would just say in a results section, or how you would describe it, there is no main effect for test type. You don't have to worry because that's saying that neither level is higher or lower than the other one. So when describing for a main effect for training type, again, it's as if test type didn't even exist. And if you are talking about the main effect for test type, it's as if training type never existed. Of course, looking at the graph on the bottom, you would say that there is an interaction, but we're not looking at that right now. Now we're just talking about how to describe the main effect. Come on. Be nice. Go to the next slide, please. It's deciding not to work. All right, let's go back to presentation mode, and now it's working. So when we're describing interactions, again, we're not using the marginal means at all. Do not use the marginal means. For interactions, we're talking about IV1 and IV2 and how they interact with one another or not. So every interaction is different. We could describe it differently if we were to swap the lines for the x-axis. And there's no one sentence structure like the main effect that would be as effective or as a specific way to describe an interaction. Since you're talking about both variables, it doesn't really matter which one you talk about. So The book tells you to use what we call the simple main effect strategy. Here, looking at the graph, there is an interaction such that for verbal tests, so you're looking at one level of the IV verbal test, and you're going to describe both of the other levels of the other IV on that one. I know that sounds very confusing. There is an interaction such that for verbal tests, vocabulary training did better than no training. But for math tests, they both scored the same. Do you see how that works? You see a big difference in verbal, so we described that difference. For verbal tests, those who had vocabulary training did a lot better than those who had no training. For math, training didn't matter, or the two groups scored the same. Come on. Be nice. You worked before. I'm going to try to be nice to it and hope that it works, but it's not. Oh, there it goes. Okay. So, again, every interaction is different. There's no simple structure. So we can say something like, when people recall at the water's edge, they do better if they learned the words at the water's edge. When people recall underwater, they did better if they learned underwater. Or looking at the one on the right, drinking makes everybody more aggressive because, as you see, as you go from placebo to drunk group, both groups are higher than in the placebo group. But this is especially true. It's even higher for those who are heavier, right? So these are different ways to try to describe it. And one of the things I'd like you guys to do on your own time is to look at an interaction and look at the variables and see if you can describe it. Because again, I normally give you guys the practice individually or even as a group to practice how to describe the interactions you see. You don't have that luxury now, so maybe just try a little on your own or go back over these slides. Come on. There we go. Is that where we were? Yes, it is. All right. So remember, here's a little practice. Just looking at the study. In one of their studies, Strayer and his students tested whether people would get better at driving while talking on a cell phone if they practiced doing so. In this case, they asked people to drive in a simulator both while while talking on a hands-free cell phone and while not talking on. In addition, the same people participated over several days, so they had a chance to participate and practice this multitasking. On the first day, they were considered to be least experienced. Of course, on the last day, they were considered to be most experienced. In addition, on the last day, they were also tested in a familiar environment. So sort of the day 1, day 2, day 3, day 4, the same. And then also on day 4 in a new context or environment. So they were tested both in a familiar environment and in a slightly different driving environment to see if the first days of practice would transfer over to a new context. Cooper and Strayer collected data on how many collisions or accidents the drivers got into on the simulator, trained in what they called the city condition. So we know that there are two IVs. We have cell phone use and we have day or driving day. In this case, we don't see a 2 by 2. And remember, we only have two variables, so it's only going to be two numbers as you see. So what kind of design is this? Well, if cell phone use is our first variable because it was the one named first in the study, we see two levels. Single task, not using cell phone, dual task, driving while using the cell phone. So the first number in this design is 2. The first variable has two levels. The second variable is the day or driving condition. Day 1, day 4 familiar, day 4 in a new context. That is 3 levels. So the second variable has 3 levels. First variable has 2, second variable has 3. We would call this a 2 by 3 design. And again, if you actually multiply the numbers, that tells you the number of cells that there are going to be in this experiment, in this table. 2 by 3, 2 times 3 is 6, and what do we see? 1, 2, 3, 4, 5, 6, 15, 6, 10, 20, 7.5, and 24. So what are the IVs? What's the DV? Well, pretty easy to figure out once again. We've been practicing this a lot. First IV would be task. So we have single versus dual, or type of phone, phone versus no phone. The second IV would be the days, day 1, day 4, and day 4. And of course, what's our DV? We can see what the number means up at the top. Our DV is the number of collisions. So indicate whether each IV was manipulated as independent between groups or within groups. Normally, when we have a factorial design, we have a between subject design, which means both IVs were between subjects. We have a within subject or within groups design, where everybody does everything. Or we could have something we call a mixed design. And a mixed design means that one independent variable is manipulated between subjects so that people are in only one group or the other. And the other one is manipulated within subject. So everybody does everything for that variable. Let's take a look. Do you think that these are between, within groups, or mixed design? Well, let's look at the first one. The first one that we talked about with 2 levels was cell phone use. Would you say that you're either single task or dual task and you didn't do both? Right? I think that's it. Single task was not using their cell phone the entire time. Dual task was using their cell phone the entire time, and they didn't do both. So definitely the first IV with 2 levels is between subjects or independent groups. Let's look at the other variable. Day 1, they tested them day 1 when they first learned, in day 4 from the same context, and then again in day 4 in a new context. And what it looks like is everybody did day 1, everybody did day 4 familiar, and everybody did day 4 in a new context. So IV2, the days, right, would be within subject. So now or within groups. So now we have an interesting thing. One IV seems to be between subjects or independent groups. One IV here, days, seems to be within subject. We wouldn't call this then a between subject or a within subject factorial design. We would call it a 2 by 3, and we would call it a mixed design, because cell phone use is a between subjects design, independent groups, and the day is within subjects or within groups. If we were to create a line for these graphs, again, we could do marginal means. We would just have, most likely, what we would do is we would have the, if it's a 2 by 3 in this case, then the 2 are usually the x-axis, and the 3 is usually the lines, because you can have 3 different colored lines for the 3 different days. So if we were to do this, you could see that for marginal means, single task cell phone, right? 15 and 6 and 10, 31 divided by 3 would be 10.3. For dual task, 20, 44, 51 and a half divided by 3 would be about 18, 17 and a half. So we have 10 and a half, 10.3, 17 and a half. You would say that there is a main effect for cell phone use or not use. Let's look at, you would have 3 lines, so you would have 3 marginal means here. Day 1, 15 and 20 is 17 and a half. Day 4, 6 and 7 and a half would be about 6.66. Day 4, 10 and 24 would be 17. Looking at these, we have 17 and a half and 17, but we also have 6.6. So you would say that of these, at least one is different from the other 2. So yes, you would say that there's a main effect. Even though day 1 and day 4 in a new context seem to have about the same for their marginal means. If we take all three into account, you don't need them to all be different from each other. You just need one of them to be different from the other two. So we would say that yes, there's also a main effect of day, right? Or driving condition or whatever. So finally, you want to know, and I don't have the whiteboard version of this or portion of Zoom available. I'm not very good at typing anyway, or drawing for that matter. I guess I'm okay at typing. But we can just look at the simple subtraction, right? So we can either do it across or down. 15 minus 6 minus 10. 9 minus 10 is -1. Looking at the next one, 20 minus 7.5, 12.5, minus 24 would be about -12.5. So either way, you see, yes, there would be an interaction. If we were to go down, 15 minus 20 is -5, which is different from 6 minus 7.5, which is -1.5, which is different from 10 minus 24, which is -14. So either way you do this, and if you were to graph it, and you guys can stop this video and graph these lines if you really want to, either way, doesn't matter if the 3 are on the x-axis or the 2, you'd see an interaction here because not all of these are going to be parallel. If you did it as 2, even with 3 points, 15, 6, 10, 27.5, 24, you would see that the lines are not parallel and we have an interaction. Now, how do we identify factorial designs? Well, what we know about them is that for articles, the methods section will state this was a factorial design with blank and blank as independent variables. Cell phone use and day of training, whatever you wanted to call it, would be the independent variables. And of course, when you look at the results section, which we will go over next week probably, maybe this week, we'll see. That will describe statistical tests for both main effects and interactions, which are usually ANOVAs or F tests. ANOVA stands for analysis of variance, if you did not know. For popular press articles, you look for the key phrases such as "it depends," right? Because you're also looking to see if levels of one variable depend on the levels of the other variable. That's why we say it depends. And you can look for participant variables, right? So if one of the IVs is gender, male versus female, or height, or hair color, or things that can't be randomly assigned, right? Things that you either have or you don't have, right? Short hair versus long hair in this case. If you have short hair, you're only in the short hair group. If you have longer hair, you're only in the longer hair group. Those are what we call participant variables, and remember, they're treated just like another independent variable. You know you want to change. Come on. Come on. There we go. Well, factorial variations. Again, as I just pointed out a few minutes ago, we have 3 different types of potential factorial design. A fully between subject or independent groups, where there are 4 groups and each group only has participants that perform one of those things. So you're either on your cell phone or not on your cell phone in this case. But a fully between group design or independent group design is that you're only in one of those 4 groups and not any of the others. A truly within group means that everybody does everything. So if there's 4 groups, everybody does all 4. In a mixed design like the one we just saw, one variable, they're either on their cell phone or not on their cell phone, is between subjects or independent group. The other one is within. They all did day 1, day 4 familiar, and day 4 in a new context. That's what we call a mixed design. One variable, one IV, is between subjects where they only do one or the other. The other IV is within where they do both. That's what we would call a mixed design. What happens if we increase the number of levels on an independent variable? And what happens if we increase the number of independent variables? So when we look at between group designs, again, both IVs are going to be studied between groups. So you're either on a cell phone or you're not on a cell phone. You're either younger or you're older. You're not both. That would be a completely independent groups or between groups design. In this case, a 2x2, 2 levels of one IV, 2 levels of the other IV, give us 4 groups. Younger on a cell phone, younger not on a cell phone, older on a cell phone, older not on a cell phone. This is also known as a between subjects factorial design. Looking at a reminder, very much like we talked about in the last chapter, if you have an independent or between group design, you will need more participants because having 12 participants per group means you need 4 groups. So you need 48 subjects if you're going to have 12 per group. In a within groups design, everybody serves in all 4 groups. So for 12, you only need 12 people total because all 12 people will do and be in all 4 groups. They'll see the alcohol and plant photo, they'll see the neutral and aggression related words, and they will be all 4. So you'd only need 12 people. In a mixed design, it kind of splits the difference. So one of your IVs is within subjects, so you only need 12 and the same 12. And the other IV is going to be between subjects, so you need 12 per group. So in an independent group, you'll have 12, 12, 12, and 12, which will give you 48 subjects. In a truly within subjects design, those same 12 subjects will go through all 4 groups, so you only need 12 participants. And in a mixed design, you would need 24. 12 people doing the same thing, but 2 groups of 12. So that's 24. In a mixed design, again, one IV is manipulated between subjects. So subjects are either only on a cell phone or only not on a cell phone, and they're not both. And the other is manipulated within groups. Everybody does day 1, day 4 familiar, and day 4 in a new context. So a mixed design is what we would call an intermediate, or it's halfway between a within groups design and a between groups design in terms of number of participants. So again, those say in the within subject design, the same 12 will be doing both levels, but you need 12 and 12 for the between group design. So in that case, you need 24 participants. If we increase the number of levels of an independent variable, as I said, you would not change how many numbers there are. If there's 2 variables, it's still going to be a blank by blank. Instead of a 2x2, it depends on how many levels. Remember, the numbers actually represent the levels that there are. So in this case, IV1 is cell phone condition, and we have 3 levels. IV2 is driver age, and we have 2 levels. So you could call this a 3x2 factorial, but the way that they do it scientifically is they just say the lower number first. So you would call this a 2x3. What about this one? Breaking onset, cell phone condition, driver age. Here we have IV1, 3 levels, hands-free, handheld, and no phone at all. And for age, it was broken down into 4 levels, 20 to 29, 30 to 39, 50 to 69, and 70 plus. So in this case, we would have a 3x4 design. And how would they look? On top, a 2x3, we have 2 lines with sort of 3 points. And on the bottom, what you see here for the 3x4, the 3 is on the bottom, and there are 4 different lines that break at 3 different points. Right? So as you go from hands-free to handheld, and handheld to no phone. On top, the lines look pretty parallel in all spots. Light parallel and only one is different. As long as there's a difference anywhere, there is an interaction, right? Because that means there's a difference in the differences. If we increase the number of independent variables, you're going to have a different notation. So now we are looking at the original 2 by 2, younger drivers and older drivers. We have cell phone condition, hands-free versus no cell phone. And now we see that there across the top is 2 more levels. Type of traffic, light traffic and heavy traffic. So cell phone and no cell phone, 2 levels. Younger and older drivers, 2 levels. Light and heavy traffic, 2 levels. In this case, because we have 3 independent variables, we call it a 2 by 2 by 2 design. Why? Because we're saying 2 levels of cell phone, 2 levels of age, 2 levels of traffic. 2 by 2 by 2. So this is a little bit different because this is what we call a 3-way design. A factorial design is a 2-way because there are 2 independent variables. Here there are 3 independent variables, so we call this a 3-way interaction. In this case, we are actually going to have 3 different interactions. We're going to have an interaction between cell phone and age. We're going to have an interaction between age and traffic. And we are going to have an interaction between cell phone and traffic. So there will be 3 different interactions. And then we want to know if all 3 of them interact. So, looking at this graph, we see that in light traffic, it's a spreading interaction. In heavy traffic, the lines are parallel. So, they are different from one another. So we would say for light traffic, in light traffic, there is an interaction because it's a spreading interaction. In heavy traffic, let me start over. In light traffic, there is no interaction between, there is an interaction between cell phone and age of driver. In heavy traffic, there is no interaction between cell phone and age of driver because they are parallel lines. But is there a 3-way interaction? That's what we're asking. Well, that's when you look at the 2 interactions or the 2 sets of graphs in light traffic and heavy traffic and ask, are they the same? And the answer is no, right? In light traffic, we have an interaction. In heavy traffic, no interaction, which means there is a significant 3-way interaction, right? Because the graph on the left and the graph on the right do not look the same. If in light traffic and heavy traffic, we both had a spreading interaction that looked exactly the same, we would say that there is no 3-way interaction. I hope this is not too confusing, and I would be more than happy to go over it with you in office hours if you needed. So, main effects and interactions in a 3-way design. We are asking 3 different main effects for cell phone versus no cell phone. Is there a main effect for age? So again, younger versus older. And we're asking, is there a main effect for traffic condition? Light versus heavy. So here, if we look at the marginal means, we have 1170 and 1010. So I would say, is there main effect for cell phone? Yes. Main effect for age of driver? In the marginal means, we would have 1197 and 982. I would say yes, there's a main effect for age. What about traffic? Well, here we see 1003 and 1176. I would say that there is also a main effect of traffic condition, right? So we have 3 main effects in a 3-way design. What about the interaction? Well, we have 2-way interactions, and then we have 2 2-way interactions, and then the 3-way interaction. Looking at younger drivers and older drivers in light and heavy traffic, we do see a 2-way interaction between type of traffic and age of driver, right? How would we describe this? As you go from light traffic to heavy traffic, younger drivers slightly increase their onset time, older drivers greatly increase their onset time. There's an interaction between type of traffic and age of driver. What about in the second one? We see cell phone versus age of driver. Looking at those, they look pretty parallel. Actually, I would say that older drivers decreases more than younger drivers. So I would say there is an interaction between cell phone and age of driver. And if we wanted to check that, 1,034.5 minus 930.5, which gives you about 104. Older drivers, 1,306 minus 1,089, which gives you about, I don't know, 215 or something like that. That's a big difference, right? So I would say yes, that means there is an interaction. If we went down, same thing, 1,034.5 minus 1,306, or 930.5 minus 1,089.5. Either way, you'd say yes. That pretty much confirms there is an interactions, a two-way interaction between cell phone use and age of the driver. What about traffic and cell phone use? Here we see that they are parallel lines, so there is no interaction between type of traffic and type of cell phone. Is there a three-way interaction though? Three-way designs means that there are three two-way interactions and there is one three-way interaction. Looking at the possible outcomes in light traffic and in heavy traffic, right? We're looking at age of driver in light traffic and heavy traffic. Is there a three-way interaction? I would say no, because we see parallel and parallel, right? Both cases are parallel and parallel. So we would say there is not a three-way interaction. Let's read the explanation. There is no, there is no two-way interaction on the left side in light traffic and no two-way interaction on the right side in heavy traffic. The two sides show the same two-way interaction. In both cases, the two-way interaction is 0, so there's no three-way interaction. Would there be a three-way interaction here? We have one crossover interaction on the left and a spreading interaction on the right. The answer is yes. So why would this show a three-way interaction? Because the two interactions look different from one another. If they were both parallel and decreasing like the top, we would say no three-way interaction. But because one on the left is a crossing interaction in light traffic and a spreading interaction in heavy traffic, the two sides show two different two-way interactions. So we would say here there is a three-way interaction. I can see where this would be confusing. That's why this is much better done in person, but hopefully I can answer any questions you may have. Again, looking at the three-way interactions, we see a crossover interaction on the left and another crossover interaction on the right in light and heavy traffic. So because those two look like each other, there is no three-way interaction. The explanation, there is a two-way interaction on each side of the figure, but the two-way interaction is the same for both light and heavy traffic. Therefore, they show the same two-way interaction, so we do not have a three-way interaction. What about here? We see crossover interactions, kind of like the one above it, but if you look at the color, older drivers and younger drivers are different in light and heavy traffic, the pattern. So in this case, we would have a three-way interaction. If you look carefully, the two-way interaction on the right on the left side in light traffic is actually the opposite of the way the interaction looks in heavy traffic. Therefore, there is a three-way interaction. A lot of times it's just repetition with these, right? So going over these examples again and again is a really good way to understand this. So why do we worry about all these interactions? Remember what I said at the beginning in the last lecture, that main effects can be important, but whether or not there's an interaction is almost always more important. So most outcomes in psychological studies aren't really about main effects, but whether 1, 2, or 3 variables interact with one another. When you look at factorial designs, again, in empirical journals and in popular press, for popular press articles, we talk about it depends, right? That one thing or the levels of one thing depend on the levels of the other. That's what an interaction is. So for a popular press article, you would look for a wording of like, it depends, to figure out if it's a factorial design. And of course, you can look for those participant variables, right? That are acting like or treated just like another IV. Age, gender, ethnicity, height, you know, eye color, things like that. Of course, like I said, in an empirical journal article, you're going to see the word factorial design. You'll see it in the method section. If you have levels that you're looking at together, that in the results section, an ANOVA or analysis of variance, anything that's more than, that's 3 comparisons or more. And if you have a 2x2 design, you're comparing 4 different groups. If you have a 2x3, you're comparing 6. So anything more than just 2 levels, right, you're going to have what we call an ANOVA. So looking at this example here, I want to go through it for you guys. I would say with you guys, but let's face it, we know it's for. A study. This study included 18 kids ages 6 to 10 whose levels of introversion and extroversion were rated on a scale by their teachers and counselors. On one day, the kids were served breakfast by adults. They were given a large or a small bowl and then told the adults how much cereal and milk they wanted to have. On another day, the kids served themselves breakfast after being given a large or small bowl, and the amount of food served, whether by the adults or by the kids themselves, was secretly weighed by scales hidden in the tables. So, what are the 3 IVs and what is the DV in the study? Well, the amount of food served, which was weighed, that's going to give you the number. That's your dependent variable in this study. So we have 3 levels. We had large or small bowl, right? That's 1 variable, which would be bowl size with 2 levels, large and small. We had whether they serve themselves or the adult serve them, so type of serving, which has 2 levels, right? Themselves or the adults. And we had introversion and extroversion, which is type of personality trait, right? So we have a 2 by 2 by 2 design. Obviously, we're not going to graph it here, but the hint is, like we just saw in those last couple slides, you'll have 2 graphs, one for kids being served by adults, one for kids serving themselves, and it would be introversion, extroversion, large, small bowl. So each graph would have 2 IVs on it, and you would see if those graphs were parallel to see if there was a 3-way. Based on this, what it showed, what your graph would look like is extroverted kids served themselves 33% more breakfast when they had the larger bowl, compared with introverted kids who only served themselves 5.6% more when they had a larger bowl. So you definitely see a main effect here. When the adults were serving them, both introverted and extroverted kids asked for more than 50% more when they had a bigger bowl. So you could, on your own, graph these results out and see if you had 2-way interactions and if you had a 3-way interaction. that is the rest of chapter 12. Later this week or later today, I will be posting a homework assignment for this chapter, and you'll have, I think, till the end of the week to do it, so look for that. All right. I thank you for listening once again. I really appreciate you guys sticking with us, sticking with me, and as always, I'll talk to you soon.